How do we save the drowning child? That's the question for today's video in our Stem the Confusion series. Welcome back. I'm Rajesh from Cloud Tutors, and this is the question we will discuss today. Now imagine a situation on a sunny afternoon. You are on the beach and you see a drowning child in the water. And your first thought, of course, is to rescue the child, and your goal will be to reach the drowning child as quickly as possible. Now, since you have to get there quickly, what are the paths available to you? Now, one of the things that you should keep in mind is the speed. Your speed on land is slightly greater than in water. Let's say it's 5 meters per second on the sand and 3 meters per second in water. So this is something you have to consider. It's faster running than swimming. That's what it means. Now, let's look at possible paths for you. That is one option. You get to the water as quickly as possible and then swim the rest of the way. Let's call it option A. Or you figure that a straight line path is the shortest path and that must be the quickest path, and you take option B. Or you may consider option C, where you cover as much distance as possible on land and then swim the short distance to the child. These are three options. There may be other options as well. Which will get you to the child quickest? That's the question. Now, if you look at all possible options for you, let's take a half a dozen different options and actually compute the time taken to get to the child. And let me present some options to you. And with a little bit of basic math, you can calculate the time required. So there is this path, and then there are multiple paths available. If the time required for each path is calculated, it turns out that the quickest way to get to the drowning child is this. Now, this is a remarkable thing. It's not a straight line path, as you can see, but this is the quickest path. And if you define two angles, I and R, in this way, it turns out that sine I divided by sine R, and I and R are two angles, that ratio is equal to the speed in medium 1 divided by your speed in medium 2, that is land and water. That is 5 divided by 3. Now, what does this equation remind you of? It reminds you of the law of refraction, Snell's law, where the deviation of a ray of light is linked to the speed of light in two different media. And this is the fastest way or the quickest way to get to the drowning child. In fact, if you look at a more familiar situation where a ray of light goes from one medium to another, let's say there are two media here. Medium 1 is the rarer medium, medium 2 is the denser. Of course, there is no medium in which the speed of light is 3 meters per second or 5 meters per second. Think of it as the ratio of the speeds of light in medium 1 and medium 2, 5:3. If that is the case, a ray of light originating from X, when it reaches the boundary of the two media, changes direction, and you're all very familiar with this diagram. It bends towards the normal. when it goes from a rarer medium to the denser. And if you define the two angles I and R, then they have the same relationship with the ratio of the speeds of light in these two media. Sin I by sin R is equal to 5 by 3. And that is the fastest way to get from point X to point Y, given that the ratio of the speeds in these two media is 5:3. So how do you save the drowning child? By doing what light would do. Follow the law of refraction. This is a remarkable principle. This was first pronounced by Fermat in 1650 or thereabouts, and his principle states that of all the possible paths that light might take, light takes the path which requires the shortest time. Now you can explain all phenomena of light, whether it is reflection, the fact that the angle of incidence is equal to the angle of reflection, or refraction like we just did, or the way parallel rays of light converge when they pass through a convex lens. Every one of them can be explained or reconciled with Fermat's principle of shortest time. And that answers two questions. One, how do you save the drowning child? And two, how Fermat's principle of the shortest time applies to every phenomena of light. Which brings me to my question for you. If the roles were reversed, you were enjoying a nice swim in the water and you see your friend on the beach in a spot of bother, and you have to get to your friend as quickly as possible. What path will you take? That's the question I will leave with you. I hope this stems the confusion as far as Fermat's principle of shortest time goes. It also connects the behavior of light to a seemingly unrelated situation of a drowning child. Thank you for watching.